Hi everyone, welcome back to my channel. Today we're going to look at another example using the binomial distribution. Please do check out the first part of this video, which I'm going to put the link down in the description below. Let's consider this question. The probability that it will rain on any given day in September is 0.3. Calculate the probability that in a given week in September it will rain on part A, exactly 2 days, part B, at least 2 days, part C, at most 2 days. To be able to answer this question using a binomial distribution, we need to know two parameters, the n and the p. The n is the number and the p is the probability of success. Now, in this question, we have been given a probability. The probability that it will rain on a given day, which is 0.3. So we have been given a p, and then the probability that in a given week in September. So have we been given the n here? Yes, in a given week. So in 1 week we have 7 days, because you're asked to calculate the probability according to the number of days. Okay, so here the n will be 7. So we can write n is equal to 7, p is equal to 0.3. Now from the p we can calculate the q, which is 1 minus 0.3, which is 0.7. So once we have our two parameters, we can define the distribution. So we can say let x, capital X, follows bin and p. So n is 7, p is 0.3. Now once we have defined our distribution, we can calculate the different probabilities. So the first one is pretty much easy, which we have already done in part 1. So still let's do it again. So part A. So we are asked to find the probability that in a given week it will rain on exactly 2 days. So therefore here my R is what? 2. So we need to calculate what? Probability of X is equal to 2. So let's use the formula. So NCR, so it's going to be 7 is equal to 7c to 0.3 to the power of 2, and then 0.7 to the power of n minus r, which is 5. So here again, if we add these two powers, we should get n, which is a 7. So using a calculator, we're going to get the answer. The answer is 0.318. Please do check out the first part of this video to see how I used the calculator to get this value. Now part B. The part B, it says at least 2 days. Now at least it means no. Part B, at least means no. It means greater or equal to. Now this is very important in statistics. Okay, so we need to calculate the probability of X is at least 2 days. It means greater or equal to 2. Now we have 7 days in a week. Now if I draw a number line, so I have 0, 1, 2, 3, 4, 5, 6, 7. So it says at least 2. It should be greater or equal to 2. So we need to consider 2, 3, 4, 5, 6, 7. So it means we need to calculate the probabilities for X is equal to 2, 3, 4, 5, 6, 7. Now, this is a longer process. Now, instead of adding all the probabilities for x equal to 2, 3, 4, 5, 6, 7, we can simply subtract the probabilities that does not include greater or equal to 2. So what are the two values that do not include greater or equal to 2? So we have only 0 and 1. So we simply take is equal to 1 minus probability of x is equal to 0, 1. That is 1 minus probability of x is equal to 0 plus probability of x is equal to 1. So once we have written this, we can calculate the probabilities. Let us work the probabilities. So we have 1 minus open square bracket. So let's calculate for the first probability x is equal to 0. It's going to be 7c 0 0 decimal 3 power 0 0 decimal 7 power 7 plus 7c1 0 decimal 3 power 1 0 decimal 7 power 6. Again 0 plus 7 7, 1 plus 6 get 7. Now using a calculator we're going to get the value. The answer is 0.671. But C is at most 2 days. Now this time it says at most. Now what does at most means? At most it means less or equal to. Okay, so part C we have probability of x is less or equal to, so the question at most 2 less or equal to 2. It means less or equal to 2. It means we need to take what? The probability of x is equal to 0 plus probability of x is equal to 1. Do we stop here? No. We add probability of x is equal to 2. So we need to have x equal to 0, 1, 2. Now, we have already calculated the probability of x equal to 0, x equal to 1 in the second part of the question. So we can use the two values. So no need to calculate it again. So we have this one plus this one. Okay. So let's rewrite it again. So we simply need to add these three probabilities. The 0.318 I got it from the first part A, which we have already done. So without calculating again using calculator, we can simply take the values from the previous part. So adding the probabilities we have 0.647. So this is the answer for part C. I hope you found this video helpful. Thank you for watching. Bye bye. Take care.